Hey everyone, this is Mr. Kier. We're going to be taking up our last mole quiz. So I just want to give you a quick overview again of what we're trying to do. So oftentimes what we'll have is we'll have a certain mass of something. So I might have a container has so many grams of a compound, and I want to know how many entities, how many things are in here. Well, the entities we could be counting, if we're dealing with a molecular compound, we could be counting molecules. If we're dealing with an ionic compound, we're looking at formula units. And sometimes we might even have a pure element like aluminum, so we might be counting the number of atoms. Nonetheless, I want to know how many of these we have. So to do that, we have to change the mass into moles. So I'm going to figure out how many moles of something I have. Remember, it's like a dozen. And then once I have the number of moles, I can figure out how many entities I have. Well, the way we do this is to go from mass to moles. I need to know how many grams there are in a mole of something. So how much is a mole? So that is going to be my molar mass. So how many grams do we have in 1 mole? So molar mass. And then once I know the number of moles, I know how many entities are actually floating around, because I know that for every 1 whole mole, I've got 6.02 times 10 to the 23 of something. So sometimes I might be going from mass all the way over, counting the types of entities that are in the container, or sometimes I might have the entities, I have to figure out how many grams there are, just going the other way. Doesn't matter, go one way or the other, it's the same flow chart. So let's look at the example that you have here. Now, just a heads up, there are 2 different versions of this quiz. If you did this quiz earlier, you would have had 27 here for the exponent. I'm going to change it to 25. It's a little bit more realistic at the end of the day, give you a better quality answer. So what we have here, we've got propane. Now, propane is a molecule. It's a molecular compound. It has 3 carbons surrounded by 8 of these hydrogens. So we're going to have this molecule. And in this particular container over here, I've got 4.64 times 10 to the 25 entities. Well, what are the entities? They're molecules. So we're going to be counting molecules today. Here we go. Molecules are floating around. Let me just make this a little bit nicer. And what I want to do is how many moles are there in here. So we're going to go from the number of entities to moles. And then once we know the number of moles, I can figure out how many grams are in the tank. So we're doing this little strategy here. We're going from molecules. We're going to determine the number of moles. And then once we have the number of moles, we're going to determine the mass in grams. And the way we do that, we're going to be using our molar mass. Remember, it's how many grams there are in a mole. And then over here, we're going to be using Avogadro's number. I know that 1 mole is equal to 6.02 times 10 to the 23 molecules. So let's get going. All right. So we're going to start by writing down what we have at the beginning. We've got 4.64 times 10 to the 25. Remember, we fixed it. And we're dealing with molecules here. Oops, it's a little slow today. Sorry, folks. It's really slow, in fact. Come on, get down. Okay. I'm going to pause for a second. All right, sorry about that. Now we're back. Okay, so we've got this many molecules, and I have to change this into the number of moles. Well, I know that if I had a single mole, I'm going to have 6.02 times 10 to the 23 molecules. So what's going to happen? The units here are going to cancel. I'll be dividing 4.64 times 10 to the 25th by 6.02 times 10 to the 23, which gives me this number, 77.0764 moles. So I've got some extra decimal places on my calculator and keep them all, but now I have to round to significant digits. Well, at the beginning, I have 3 significant digits, so I need to have 3 here as well. So therefore, you've got 77.1 moles of methane in the container. All right, so we're going to do part C now, the last little bit here. Now that I know the number of moles, I'm going to figure out how many grams there are. What's the mass inside this container? Well, to do that, I'm going to use the unrounded value. So it'll be 77.07 0.64 moles. In fact, I'm going to use even more decimal places. I never cleared my calculator. They're still on my calculator screen. So then what I can do is I'm going to take this and, oh, I need to know the molar mass. Well, to do the molar mass, we'll do the quick calculation at the side. I've got 3 carbons. Each carbon is 12.01. So the mass of 3 of them is going to be 36.03 grams. Bring this up a little bit. I'm also going to have 8 hydrogens. Each one is 1.01 grams, so 8.08 for all of them together. We add everything together, 44.11 grams in a mole. So now I know how much 1 mole would weigh. So what I do now is I do this. I say 1 mole has a mass of 44.11 grams. Well, I've got more than that. I've got lots of moles. So what's going to happen here, the moles are going to cancel, and we're going to end up with a number like this, 3399.84 what? Grams. It's going to be grams, okay? So I have to now take this, I have to write it with the correct number of significant digits. So to do that, to round it to 3 significant digits, I have to round right here. Got a bit of a problem. This rounds to 3,400 grams. I can't leave it like this. So what I have to do, I have to round it properly. And the only way to write down the rounded version would be to use scientific notation. So this would be equal to 3.40 times 10 to the 3 grams of methane. And there you go. I'm done. So again, we went from molecules to mole and then to grams. So make sure you show all the units canceling. That's very, very, very important. All right, let's look at the next example here. Okay. Okay, so in this next question, we've got aluminum chloride, and I've got, 228 milligrams. What does that mean? Well, if I've got 228 milligrams of aluminum chloride, that means I have to convert it into grams. I can't use milligrams. So we know that there are 1,000 milligrams in 1 gram. So we have 0.228 grams of aluminum chloride. Okay, so you should show your work if this is some kind of assessment, just to prove that you know this relationship. So now we're going to be going through the problem. So it looks like we're going to be looking at grams. I have to figure out entities. Oh, and I have to figure out how many ions are present. So what we're going to do is this. We're going to go from my mass in grams. So we're going to have 0.228 grams. We're going to have to change this into moles. And the way we do this is molar mass. So if I have to figure out how much 1 mole is in terms of the mass. And then once I have the number of moles, I can figure out the number of formula units. And then if I know the number of formula units, I simply multiply by the number of ions. So in this case, I'm going to have 3 chlorine ions per formula unit. So that's going to be the strategy that we have here. So first thing we have to do is we have to determine the molar mass. Okay, so how much does 1 mole weigh? So at the side here, I'll show the calculation. So I've got 1 aluminum. Aluminum has a mass of 26.98 grams. 3 chlorines, 35.45 times 3 is 106.35 grams, giving me a grand total of 133.33 grams in a mole. So I have a mole of aluminum chloride. It would have a mass of 133.33. I don't have that. I have a lot less. Well, let's see how many moles we actually have. So now I've got 0.228 grams of aluminum chloride. And I know that if I have 1 mole, so I'm going to make sure the mole's at the top, I've got 133.33 grams. So the units are going to cancel. Have a little bit of division happening here. And I'm going to end up with, where is it here? 0.00171 moles. And it makes sense because I only have 0.228 grams, not even a whole gram. And 1 mole would be 133.33. So the next thing I have to do now is I have to take this and I'm going to determine how many formula units we have. So we're over here right now in a little checklist. So to do that, I'll do this just over here. Again, I have extra decimal places on my calculator. I am not deleting. They're still there. So I've got this many moles of my aluminum chloride. And I know that every 1 mole has 6.02 times 10 to the 23. Well, what are we counting here? Remember, we're counting formula units. This is an ionic compound. So formula units. And once I calculate this through, I end up with this. So 1.0294 times 10 to the 21 formula units of aluminum chloride. Okay, so the mole part cancels here. So almost there. So now we've got the number of entities. I have to do a little bit of rounding. Looks like I've got, what, 3 significant digits? So it should be 1.03 times 10 to the 21 formula units of aluminum chloride. Okay, let's do the very, very, very last step. We're almost done. We're so close to being done, aren't we? So the next step is this. We have to take the formula units and figure out how many chlorine ions there are. So I'll take my value here. Again, it's my unrounded value I'm going to be using, whatever's on my calculator. Okay, here we go. So I got these formula units of aluminum chloride. And I know that every one formula unit of aluminum chloride has 3 chlorine ions, right? Right there. So what's basically happening, I'm going to multiply this number by 3, which makes sense. I got 3 times as many chlorine ions than formula units. So this will cancel. You want to make sure unit cancellation. And you have 3.088 something times 10 to the 21 chlorine ions. Make sure you show the chart here. Okay, now final answer with significant digits. So therefore, you'd have 3.09 times 10 to the 21 chlorine ions in your particular beaker. So not very much. Well, look, it's a lot, but again, it's not much. You don't have very many grams at the beginning to start with. So that's it. Just be careful. Show all your unit cancellation. Show your molar mass calculation. And don't forget to round at the end with the appropriate significant digits. That's it.